Okay, hi, my name's Tom, and as of exactly 2 days ago, I'm a PhD student in Explainable Artificial Intelligence at the University of Bristol. Thank you. I'm going to attempt to explain to you what my PhD topic is about, why I believe it's important, and why it lies at the absolute heart of what we mean when we talk about socially responsible AI. So a human Go player makes a weak move that loses her the game. A company's hiring policy appears to show gender biases. A person crashes their car. Our immediate question in each case is why? Our social norms, laws, and fundamental ethical principles rely on the assumption that decisions and actions have explanations that give insight into their context, causes, and consequences. Explanation brings trust and understanding. It's how we learn about the world and communicate our knowledge to others. It's also how we diagnose flaws in any social or technical system to change it for the better. But context, causes, and consequences are very broad scope, and our understanding of what actually makes a good explanation is limited. I chose these three examples because, in recent years, they've all been targets of research in the AI community. Today's performance is impressive and headline-grabbing in many cases, but it's not perfect. Machine learning models make mistakes, and we may rightly ask why. My key point is that while we should still demand explanations from AI systems, it's really difficult to actually get them. This is because today's AI, as we've seen, largely consists of so-called black boxes. Data from the real world goes in, lots of complex mathematical things happen to make sense of it, and predictions come out the other side. Only those outputs that are actually requested explicitly are produced. They come with no surrounding rationale or clarification. They may be appropriate, but they may be dangerously flawed, and it's hard to tell the difference. You can try to look inside a black box, but you'll see something like this. Fundamentally, AI is built out of equations whose parameters are modified using statistics and calculus. There are no semantics here, no building blocks of an explanation that a normal person would find meaningful. It's numbers and equations all the way down. So far, the AI field hasn't really had to worry about this. Research takes place far away from the real world in the realm of video games and narrow toy problems, as they're called. Commercial uses are also pretty inconsequential. When my smart speaker mishears a voice command, I don't demand an explanation because, while frustrating, the mistake really barely matters. Where the risks are low, we can bury problems like this. A clear exception is the content recommender systems on modern social networks. It seems clear to me, at least, that some of the fractures in modern politics are due to how these complex algorithms work to optimize their ad revenue in a way that their creators could not easily foresee or control. This is really the first AI application with much freedom to interact with humans, and the results are pretty scary. And we can look forward to many more ambitious uses of AI, far more integrated with our social fabric as part of our legal system, for example, or with the physical world through robotic embodiment. In these inevitable future applications, human welfare and human lives are very likely to be at stake, and transparency, trust, and verifiable safety are essential. So the stakes are yet higher in large-scale transport and infrastructure applications, where many of us are dreaming of dramatic performance gains, but where safety is paramount and there is no room for unexpected behaviour. So everyone has their own beliefs about the military use of AI, but if it did become commonplace, a complete understanding of its capabilities and limitations would be completely essential. So what now? Well, as ever, the first step for the AI community is to acknowledge we have a problem, and I think over the last 2 or 3 years that is broadly starting to happen. The term explainable AI is now a recognised one in academia and industry, and this is a great thing, but what would explainable AI really tangibly look like? Well, here's the Silicon Valley approach, and we know what we think about that maybe. Train a second machine learning model on data of human decisions and associate written explanations, and use this to explain how our main AI system operates in the real world. Believe it or not, people have been trying this kind of approach, but for me it dangerously misses the point because we now have 2 black boxes instead of 1. And in this situation, we could risk the problem of confabulation, by which I mean learning plausible explanations that in reality are completely false and don't deserve our trust. We know this is a risk for complex learning systems because the human brain does it all the time to rationalise our highly irrational actions after the fact. In the opposite direction then, we could try to avoid complexity entirely and only use simple models in high-stakes situations. Many view techniques like linear regression as inherently interpretable in some way because they have so few moving parts. In the case of decision trees like the one shown here, any decision can be given a natural language kind of explanation by following the path through the tree to get there, and it almost acts as its own explanation. But it's widely accepted that by doing away with complexity like this, we almost inevitably sacrifice performance. So one solution to this could be to distill the core functions of a complex model into a kind of simpler one that we can use to query to gain some understanding about how it operates in general or how it came to a specific decision. And this is a possible avenue that I think I'll be exploring. Alternatively, we could use visualization to help build our own mental models about AI systems. In these figures, the researchers have tried to tease out how an image classifier represents objects like buildings and insects, and also determine which parts of a specific image it looks at when searching for a cat and a dog. And the results are quite intuitive and gives us some grasp that things are going along the right lines, and this is great. Thus far, I've been quite hand-wavy though, about what makes an explanation actually correct or even valid. But the work of Udia Pearl could be a crucial guide here. In his books, Pearl takes the common idea of correlation not implying causation and formalises it mathematically. He's the only person to have really done this. He claims that explanations are only meaningful when expressed in terms of scientifically testable cause-effect relationships, as shown in causal diagrams like this, which can be used to answer any question we could possibly ask about why certain things happen and how they might come about in the future. Currently, human experts are needed to define these relationships, and a causal discovery automated mechanism is a massive open problem in AI. So nothing like these diagrams exist in today's data-driven learning systems, and they're blind to the mechanisms of the real world for that reason. So at present, things are quite bitty. We have some good building blocks of explainability, inherent transparency through simplicity, distillation of complex models into simple ones, visualizations that allow us to build our own mental models of how systems work, and a rigorous definition of what it means to be causal. But we're lacking a holistic paradigm to bring it all together. So explainable AI is a new and exciting field containing many fresh ideas that warrant much deeper exploration. With trust, fairness, accountability, and safety on the line, AI researchers like me have a real social responsibility to solve these problems with the help of experts from many other fields, including anthropology. Thank you.